We were looking yesterday at what are called compositions of functions, where one function becomes the input for another function. So for example, and I think the best way to review this is to just do a couple of quick examples here. I'm going to avoid number 1 just for the time being and go to something like number 3. If I say to you, what is f of g of 1, which could be written this way, so this is A. What this means is, obviously because it's what it says in the question, f of g of 1. Well, if you want to figure out what g of 1 is equal to, and this shouldn't be anything new, g of 1 is the result of putting 1 in for x and g. And you can calculate that number, and I would never teach the lesson to you this way. I think this is overkill, but g of 1 is 3 times 1 minus 2. So g of 1 is 3 minus 2, which is 1. And that means f of g of 1 is f of 1, coincidentally. And that means put 1 in for x in f, which means it's 2 times 1 plus 8. So you get 10. I think there's a more streamlined, literally and figuratively, a more streamlined way to figure out what f of g of 1 is. This means that 1 is going to go into g, and the result is going to go into f. And the reason why I think that's preferable is because we could have 3 or 4 functions that are feeding each other, and I think doing this that I've got on the side of the board here kind of in steps, it kind of gets confusing. You might get lost in terms of what it is you're doing. So all this means is feed 1 through g, whatever you get coming out, feed it through f, and then this is your answer. Now, when I say feed the numbers through, it could be like question 3 that you feed them through by putting the numbers in for x in an equation. But it could be like 2, feeding the numbers through could mean you look at a graph. So for example, if I say to you, what is g of f of negative 3? Well, negative 3 gets run through f. The result gets run through g to get the answer. And what you need to remember about a graph is this is the input and this is the output. So if you want to run 3 into f and see what comes out, then you go over to 3, negative 3, you go over to negative 3, and for an input of negative 3, you look at the y coordinate, which is the output on f. That would be 1. So 1 comes out. But now 1, which is the y coordinate of f, becomes the x coordinate of g because it's going into g. So now you go over here to 1 and you read what g is, and it's negative 5. Or, I mean, there's other ways you could get the numbers. Like this one kind of threw some of you right at the beginning of yesterday's practice session, which is, okay, so if you're asked to find, I'll pick this one today, g of f of 3, 3 goes through f, the result goes through g, and then you have your answer. Well, you don't have a graph that you can feed x equals 3 into. You don't have an equation, but you are literally told up here that f of 3 is 4. That means when x is 3, y is 4, which means 4 comes out of f when x is 3. Now, you don't have an equation for g that you can feed 4 into. You don't have a graph for g that you can look at the x coordinate of 4, but you are literally told what g of 4 is. It's equal to negative 1, which means that when x is 4, y is negative 1, which means when the input on g is 4, the output is negative 1, so that's your answer. And I think as long as you understand this input turning into an output, and that output becomes the input in the next stage, I think you're okay. You just have to do a little bit of sleuthing to find out what those numbers are. Does anybody have any questions you would like me to go over from this? Kendra? 5A. 5A? So we have f of x equals x squared plus x, and g of x equals x squared plus x. Unless I'm missing something, f of x and g of x are the same function. Just as a side note, when you're asked to find in A f of g of x, do you see that when you find g of f of x, you're going to get the same thing? Okay. And in fact, I could ask you in A to find f of x, and it has to be the same thing as well. Okay. But if we follow the rules here, f of g of x means that g of x goes in for x in f of x. That's what that means. So this will be equal to x squared plus x squared plus x squared plus x. To maybe make this a little more visual, what f of g of x means is that this whole thing, which is g of x, goes here and here. Okay, so we would have to simplify that. This means x squared plus x times x squared plus x, and then we have plus the x squared plus x. I don't really need brackets around this x squared plus x. I'm going to FOIL this out, so first is x squared times x squared, which is x to the 4. My outer will be x cubed. My inner will also be x cubed. My last will be x squared, and then I have plus x squared plus x. You okay with that? So the polynomial function that results for f of g of x will be x to the 4 plus 2x cubed plus 2x squared plus x. And, you know, just a very subtle difference. If I were to find now g of f of x, what's going to happen here is that this whole thing goes in here and here because we're going the other direction, but it's the same result. Have I answered your question? Yeah. Okay, good. Any other questions? Go ahead, Sasha. 10. Okay, let's take a look at number 10. Interesting question. So you have s of x equals x squared plus 1, and you have t of x equals x minus 3. And it's a little bit wonky because we're not seeing f and g and h and those typical letters. We're seeing s and t. But you're asked, is s of t of x the same as t of s of x? Okay. And what that means, there's a lot of ways we could demonstrate if it's false. You could pick a number, for example, and find s of t of 3. We could figure that out. This means that I put 3 through t and then put the result through s and get an answer. So if I put 3 through t, I didn't pick 3 intentionally, it was just a number that popped into my head. I get 3 minus 3, which is 0. And if I put 0 in for x in s, I get 0 squared plus 1, I get 1. Okay? So this is equal to 1. I could as well, if I wanted to, figure out what t of s of 3 is equal to. This, of course, means I put 3 through s, get a result, and that result goes through t, and I get an answer. So when I put 3 in for x in S, I get 10. 3 squared plus 1 is 10. When I take 10 and run it through t, I get 7. So my answer here is 7. And what I've done is I've demonstrated that there's at least one number where the functions are not the same. Now, what if you did that and you did get the same number? And you tried a different number and you got the same result. You tried a different one, you got the same result. You will never be able to prove that it's always true by choosing numbers. So what you really should be doing in this question is finding S of t of x, which means we're going to put t of x in here and get S of t of x is equal to x minus 3 quantity squared plus 1. And expanding that out is trivial. Well, not trivial. It's important. You can do it, but it's not a big deal. X minus 3 quantity squared means x minus 3 multiplied by x minus 3. And when you FOIL that out, you get for S of t of x, x squared minus 6x plus 9 plus the 1 is 10. This is S of t of x. If I find out what t of S of x is, I have to take this and put it in here. I have to put S of x in for x in t of x. And I'm going to get x squared plus 1. That's just gone right here. X squared plus 1, and then minus 3. And that means that S of t of x is equal to x squared minus 3. And now we've demonstrated that it's just not the case that it's always true.
You put a 4 on the first one.
Oh, thank you. Better? Okay. Did that answer your question? Okay. Any other questions? I want to just quickly show you something. If I have f of x equals 3 to the x, and I have g of x equals log base 3 of x, I would like everybody to figure out what f of g of 7 is. Which means you're putting 7 through g, you're taking the result and putting it through f, and I'm asking you to figure out what that number is equal to. So you have to find the log base 3 of 7, and then you need to take 3 raised to that number. How many of you know what the answer is without doing anything on your calculator? Or you suspect? It's 7. So is that a coincidence? Just show it to you just in case you're unsure what we have to do here. Log base 3 of 7. Well, I think all of you have a calculator that can handle log base. So I'll just do it this way. You go to your math, you scroll up or down to get log base. Log base 3 of 7 is this number, and now I take 3 raised to that number, and I get 7. And in fact, I won't spend too much more of our time on this, but if you do that with any number in these two functions, you get the same number. The reason is these two are inverses of each other. And although we talk about inverses in terms of x and y swapping, you can certainly explain it that way. Inverses in a more general sense are opposite operations. They're opposite. So, for example, f of x equals x plus 3 and g of x equals x minus 3 are opposite operations. Whatever one function does to x, the other one undoes. So if I put 10 in for x and x plus 3, I get 13. If I feed that into x minus 3, I get 10. Just a point of interest because you might encounter something like that on an exam. Let's move on. We're going to just go through a boatload of examples today dealing with further types of questions involving composite functions. So this is on page 20 of your unit handout. What are our objectives? Continue to apply knowledge of composite functions and analyze composite functions and function operations at the same time, also involving more than two functions. So a composite function is what we just finished talking about. Function operations are sums, differences, products, and quotients. So we're going to just throw this all into a big bowl and mix it up. First example, though, and I have to go through this because I saw a problem like this on a diploma exam a number of years ago, and it really stumped the province. It gives you a function here, h of x equals x plus 2 squared plus x plus 2 plus 3, and it says if h of x is f of g of x, then what's f of x and g of x? And I would say that some people see it immediately. How many of you know immediately what the answer is? Okay, what is it?
Well, g of x will be x plus 2.
Excellent.
X will be x squared plus x plus 2.
The key in seeing that is recognizing that what you really have here for the composite function is a thing that's squared plus the same thing. So that x plus 2 must be some input from another function. And that means that you can think of the original function as just x squared plus x plus 3, and the function that's going in is the x plus 2. And there's no, I don't know what to say. There's no algebraic approach to this. It's just you have to see it. So you have to come up with two functions where if you put one of the functions in for x in the other function, you'll get that. For example, with this one, I can very easily just say that f of x is the square root of x, and g of x is 3x plus 1. Because then f of g of x means I put 3x plus 1 in for x in the square root of x, and I get the result. Now, I don't know that this would ever happen on a diploma exam or my exam on a written response, but I had a student, and at first I thought they were just being kind of a smart aleck, but I think they were genuinely sincere. This was a few years ago. They said, would it be wrong to say that f of x is 3x plus 1, and g of x is x? No, it's not wrong. I think it's a cop-out, because no matter how complicated it is, you can do that, right? I mean, you could, over here, say f of x is x plus 2 quantity squared plus x plus 2 plus 3. And in fact, you know, had a student said, when I give you this question, had they said, can I use f of x equals that, and I stopped listening at that point, my answer would have been no, because that's h of x. But f of x could be that. You would just have to put for g of x, x. You see what I mean by a bit of a cop-out? It's just it'll always be that way. All right. Another question that, and then we'll get into the compositions algebraically speaking, but another question that you might see something on an exam, and unless you've seen this in action, you might be a little confused. When a rock is dropped in the water at a lake, you get a circular wave that spreads out. And the radius of the circular ripple is defined by the time after the rock hits the water. And it turns out that the radius as a function of time is 0.25 times the time. And I'm going to write that without the function notation. And I'll just mention to you there's a physical reason why this is the case. It's because the wave moves at 0.25 meters per second. And if you multiply speed times time, you get distance. Okay. On the other hand, you're told that the area of the circular ripple is pi times the radius squared. Now, what makes this a little bit different than everything we've been dealing with composite functions is in all of the composite functions we deal with, the variable that's independent is x. Like if I make a composition of these two functions, x is the independent variable of each of the two functions. And it means the same thing on the graph. It's the x-coordinate. But here, the independent variable is a totally different thing. In this function, the independent variable is time, and in this function, the independent variable is radius. Okay. Again, what I've chosen to do here so far is not worry about the function notation aspect of these functions. But I can't run away from the function notation when I'm asked to find a of r of t. I can't. But I want you to notice that a of r of t, this is tricky. R of t is the radius. Right? R of t is the radius. This is the radius. And area is a function of the radius. So on the one hand, the very first step in finding, say, an area, if you knew the time, was you could calculate the radius from the one function, but then you use the radius to find the area of the other. What this is asking you is not to have area as a function of radius, but it's asking you to find area as a function of time. And one other way to look at it is this is saying take time and feed it through the radius function to get a radius, and take that radius and feed it through the area function to get an area. All it boils down to is an algebraic substitution. If area is pi r squared, I want to get rid of this r again. If area is pi r squared and the radius is 0.25 times the time, then that's the area as a function of the radius as a function of the time. And we can simplify this. 0.25 squared is 1/16, I believe. 0.25 is a quarter. When I square a quarter, I get 1/16. So we get the area is equal to pi over 16 times the time squared. And I hope that at least if you've seen this and you see something similar on an exam, you don't stare at it and go, what does this have to do with Math 30? It's a composite function. All right, let's get into the meat of this lesson. This is what I mean by combining different operations and having possibly more than two functions. First of all, what you're asked to find in question 3A is not got anything to do with compositions. Nothing to do with compositions. This is simply saying k of x is equal to f of x plus g times h of x, which means k of x is equal to f of x plus g of x times h of x. And I certainly don't believe you need to write that middle line. You could just go right to there. And all we're asked to do is put this together now and simplify it. So what do we have? F of x is 3x minus 2. G of x is x squared plus 4, multiplied by, in brackets, multiplied by x over x minus 2. I see that, thank you. I'm going to space this out a little bit. K of x is equal to 3x minus 2 plus x plus 2x minus 2 times x over x minus 2. When I'm multiplying a fraction, I can just put the entire denominator over the whole product. The x minus 2's cancel, and I'm left with k of x is equal to 3x minus 2. Again, these cancel. Then I have plus x plus 2 times x. There's a point in all of this work with the algebraic operations of functions and compositions of functions where it becomes obvious that you should simplify it. And there's a point where it's very clear that you don't want to. I think you should simplify this. You should expand this out and get k of x. When I multiply this out, I get x squared plus 2x, and then I have my plus 3x minus 2. So k of x is equal to x squared plus 5x minus 2. Are we okay with the algebra? Is k of x a quadratic function? No, it's not. Because x cannot equal to 2. It's a rational function. Right? The classification of what you call a function is based on what the function is before you start messing around with it. Okay, all the non-permissible values need to be included. What is h over f times g of x? Well, that simply means h of x over the product of f of x and g of x. So I think this question is going to give us just a little bit of a workout with fractions. We have for h of x, what do we have? X over x minus 2 over the product of 3x minus 2 and x squared minus 4. And I've really highlighted the fact that the main fraction has a numerator over that thick line and the denominators under the thick line. Whenever you're dealing with any kind of, so I'll pause there. Any questions with that so far? Whenever you're dealing with any kind of rational expression, you want to express everything in factored form. I don't know why I'm switching colors back and forth. Doesn't matter. And this is so deceptive. I know that many of you will want to cancel the x minus 2's, and you cannot. You can't cancel them. You could if this were the fraction, but it's not, and it means something different. This is a complex fraction. We are going to have to multiply the top of this fraction and the bottom of this fraction by any mini denominators. It's a complex fraction because of this x minus 2 as a denominator of the numerator. So we got to multiply top and bottom by x minus 2. And what actually happens is the x minus 2's don't cancel, they build up on the bottom. In other words, everybody, 3/5 divided by 5 is 3/25. And I hope you can confirm that on your calculator. There's other ways to confirm it. If you take 3/5 divided by 5, you don't get 3. The 5s don't cancel. So what we end up with is x on the top over 3x minus 2. Then we have an x plus 2. And then we have an x minus 2 squared. And I don't think there's any need to write the non-permissible values unless you're asked to, because nothing canceled. If something canceled, you'd want to write them, because when you cancel them, you don't see them. Any questions with that one? Okay. Whew. H of g of f of x. So what does this mean? It means that f of x goes into g, and the result goes into h. And although I recommended with numbers not to do it in stages, I think you might want to do it in stages here. I think you might, for many of you, want to find g of f of x first. What is that going to be? Well, g of x is the input squared minus 4. F of x is 3x minus 2. So this is g of f. I better just check. G of f. See, remember yesterday when I said if you think you're never going to stumble or make a mistake, you're probably wrong? I thought I did, but this is right. F of x, which is 3x minus 2, goes in for x in g of x. And my recommendation is, everybody, before you start putting this into h, why don't you simplify it first? There's nothing wrong with putting this thing right here and right here. But I think if you simplify it first, you might be better off. 3x minus 2 quantity squared is 9x squared minus 6x minus 6x. And then we have plus 4 and minus 4. 3x minus 2 quantity squared means 3x minus 2 times 3x minus 2. So I FOILed it out. Are we in agreement on getting 9x squared minus 12x plus 4? That 4 at the end, then 4 is subtracted from the whole thing. So we end up with 9x squared minus 12x. And in many ways, the first part of this lesson is just an exercise in practicing your algebra. There's not really anything new. And that means that h of that would be h of 9x squared minus 12x, which would be 9x squared minus 12x over 9x squared minus 12x minus 2. So I've put in for x in the top and the bottom of h, g of f of x. Now, the top factors. We could take a 3x out of the top. Don't do anything just yet on paper, but we could take a 3x out of the top and be left with 3x minus 4. And the bottom is a quadratic, which means it might be factorable. I hope it's clear the only reason why we would want to even pursue this avenue is in the hopes of something canceling. I don't think, even if 9x squared minus 12x minus 2 is factorable, I know 3x minus 4 is not going to be a factor. But is it factorable anyway? You can do the b squared minus 4ac test. 144 plus 72 is 146 is 216, I think. 216 is not a perfect square, so it's not factorable anyway. Any questions with C? Jack?
Would you have to make it so that 9x squared minus 12x minus 2 could not equal 0 for the full answer?
No. I know what you're saying, And there, was it 216? Okay. That's not a perfect square, but it is a positive number, which means there are numbers for x that make the denominator 0, which means there are non-permissible values here. Since they come about from something that doesn't cancel with the numerator, there will be two asymptotes. I think, though, finding where those asymptotes are is really a Math 20 idea. And I think your question of saying, should we write that anyway, the non-permissible value? It wouldn't hurt, but I don't think in this case you need to.
Okay, even if it was on an exam or something?
Yeah, you know, if it were on an exam and it were written response, I would probably just write them. Even here, you know, I kind of just shrugged away the non-permissible values here because I said nothing canceled, so you don't need to write them. You know, if I were writing a diploma exam and I got this, I would put comma or semicolon, x is not equal to 2/3 or plus or minus 2. And I'm not making light of your question because I think it's an important one, but in the time it takes you as a student to say, geez, should I write them down or not on a written response, you could have written them down anyway. You know. And again, that's a positive comment. I think it's an important thing to consider. D, h of g of x. So I'm going to take g of x and feed it into g of x first. So what this means, just to show it to you a different way, g of x goes through g of x, the result goes through h of x, and this will be k of x. So I'm doing the first step. G of x. Well, g of x is the input squared minus 4. If I'm going to feed g of x in for x in there, I get x squared minus 4, quantity squared minus 4. And just because I know where this one's going, we're not going to simplify that. It doesn't go anywhere, we'll just leave it that way. That is this. It's x squared minus 4, quantity squared minus 4, and that needs to go in for h. Not for h, I misspoke there. It needs to go in for x in h. So h of g of x will be equal to, well, h of x is the input over the input minus 2. So it will be x squared minus 4 quantity squared minus 4 over x squared minus 4 quantity squared minus 4 minus 2. And if you want to rewrite the whole thing and put that minus 4 minus 2 as minus 6, go ahead. We know it's negative 6. In fact, it's so obvious, I think if you left this as your answer, don't push the marker. But if you just forgot to do that, the marker would probably go, well, the student knows the work. Okay. Oh, back to some numbers. Numbers are easier in my mind. What is f plus g plus h of negative 2? It means f of negative 2 plus g of negative 2 plus h of negative 2. And we're in learning mode right now. Of course, if it were a written response, you would show how you know that f of negative 2 is negative 2. You put negative 2 in for x up here. 3 times negative 2 plus 4 is negative 6 plus 4, which is negative 2. G of negative 2, you would show this on an exam, but you put negative 2 in for x in g. Negative 2 quantity squared is positive 4. 4 minus 9 is negative 5. Do you get my idea here that I'm not going to write down every substitution, but you would have to on an exam written? If I put negative 2 in for x up here, I happen to get negative 2. I will show this one. This will be negative 2 over negative 2 plus 3. Well, that's negative 2, because negative 2 plus 3 is 1. Well, you add these together and you get negative 9. That's the answer. I kind of like this part of the course because it's, as long as you know what to do, you just have to do it. There's no trickiness to it, usually. What does that mean? G of h over f plus g of 2. It means g of h of 2 over f of 2 plus g of 2. And the way I view this thing, and I would recommend it to a student, is you view it as 3 tasks. You have 3 things to find. What is, for example, f of 2? Well, you put 2 in for x in f. 3 times 2 is 6 plus 4. F of 2 is 10. What's g of 2? Well, put 2 in for x in g, and you get 4 minus 9, which is negative 5. I really highly recommend not doing the composition part just always in your head all the time. It's so simple to get backwards. It just, I know from experience that students will do this. So this really helps focus your brain on what it is you need to do. 2 goes into h, which gives me 2/5. And then I have to take 2/5 and square it and subtract 9. And I know you guys would just prefer to use a calculator, and you can go ahead and do that. I want to say negative 221 over 25. Yes? So I now have this, which I can just clean up the bottom a little bit. Negative 221 over 25 over 5. Look at how I drew that over. Can I cancel those 5s? No, I cannot. But I can multiply the top and the bottom of this by 25 and get for an answer negative 221 over 125. Or, I mean, you could just use your calculator with a bunch of brackets. I don't care. And neither will a marker here. That's not what they're testing your ability on. If they want to test your ability to work with fractions, it would be algebra, not numbers. G of f of h of 3. 3 goes through h. That goes through f. That goes through g. And this is your answer. And even as I'm talking and writing that, I'm going, geez, Paul, are you right here? So I always go back to this idea, from the inside to the outside. So 3 goes into h, that goes into f, that goes into g. 3 into h is, don't just be a passive learner here or a passive person, just be active in the work. Is it 1/2? Okay. 1/2 goes in for x in f, and I get 11/2, but I would like some confirmation. And I'm doing this in my head, but you, of course, would use a calculator. Is it 11/2? 11/2 then goes in to g. (85/4)? Okay. So the answer is 85 over 4. F of g of negative 1 over h of negative 1 times g of negative 1. Well, f of g of negative 1 means this. Negative 1 through g gives me negative 8. Can I get Hallelujah on that. Good. Negative 8 through f gives me negative 20. Another yes? So we have negative 20 on the top. On the bottom, h of negative 1, I put negative 1 in there, and I get negative 1 over positive 2. I get negative 1/2. Multiplied by, I put negative 1 in g and get, well, negative 8. Correct on both accounts on the bottom? Good. Negative times negative on the bottom cancels. 8 times 1/2 is 4. 20 over 4 is 5, so it's negative 5 because of that negative on the top. And maybe what can be a frustrating thing is this could be a numerical response question where you're given that and you're told that this is equal to negative a. What is the value of a? There's just so many places you can do wrong here. There really is a lot of places you could just multiply wrong or write down the wrong number. Okay, now we're going to do some with graphs. What is f minus g of negative 5? Well, this means f of negative 5 minus g of negative 5. From a very clinical standpoint, maybe too analytical, f of negative 5 means negative 5 goes in and what comes out is the y-coordinate. So you look over here at negative 5, and for f, what comes out is 4. A more straightforward approach is for you just to know that f of negative 5 is the y-coordinate when x is negative 5. And it's 4. Minus g of negative 5 means we still look at negative 5 for x, but now we read the y-coordinate or the output for g, which is 6. And I get negative 2 here. Are you in agreement with me? Okay. Would you be in agreement that g minus f of negative 5 would have to be positive too? I don't think we need to read those points again. What about f times g of 3? Well, this just means what's f of 3 times g of 3. So you go over to 3. There it is. Well, f of 3 is 2, and g of 3 also happens to be 2. So it's 2 times 2, which is 4. Still good? G of f of 3. Okay, so this means 3 goes in through f. Whatever comes out goes through g, and this is the answer. So a number going in is an x-coordinate. 3 goes in. What comes out of f is 2. I mean, if you happen to read the wrong graph, it's still 2, but it's 2. This 2 comes out. I made this point yesterday, but I think it's a very important point. That 2 is both a y-coordinate of f and an x-coordinate of g, because it's coming out of f, but it's going into g. So now you look at x equals 2. You look at x equals 2, and we want to read the y-coordinate of g, which is the absolute value function, and it's 1. Are we in agreement there? Good. F of g of 3. So we just did g of f of 3. Let's do f of g of 3. Well, I'll write it down again. 3 this time goes through g, then whatever comes out goes through f to get the answer. 3 goes in, and for g, 2 comes out. 2 now becomes the x-coordinate for f. So you look at 2, and the y-coordinate, the number coming out, we're going to estimate to be 1.4. Sorry, 2.4. 2.4. Give you a second to work this one out. F of g of f of 3. It's almost a paradox. It's very easy to get overconfident here, and it's very easy to get gun shy, like meaning really apprehensive and unsure of yourself. It's easy to be on one end or the other. And I usually am a little gun shy. Without actually writing everything down, I'm a little unsure of myself. What do we do? 3 through F, which gives 2, 2 through G, which gives 1. I think I have it. I almost said 0, but it's not 0, it's 2.7 roughly. So when 3 goes in, what comes out of F is 2. When 2 goes in, what comes out of G is 1. When 1 goes into F, what comes out is that number, which is about 2.7. Now, if it were on an exam, it wouldn't be a numerical response question. It would be something like f of g of f of 3 is a number between which two integers? And the answer would be between 2 and 3. Give you a second to do this one. How many of you have it? 1? Yeah, it's 1. 4 goes into F. What comes out is the number 1. 1, which is right here, goes into G. This is G. What comes out of G is 0. G is the final stage. We're going to put 0 into G, and what comes out is 1. So this is equal to 1. All right. What is the domain of the quotient of these functions? Well, they have a common domain of x is less than or equal to 4. Is that the proper domain for f of x over g of x? What do we need to include here in our statement, Kendra?
That it's not allowed to equal 0? Or that g of x is not allowed to equal 0?
That what?
G of x?
Right, that g of x is not allowed to be 0, but g of x is equal to 0 here, so we say x is not allowed to equal 1. Because g of x is the quotient, you can't have the quotient being 0 and the quotient is 0 when x is 1. What would be the domain of this? With this one, I can get away with saying x is less than or equal to 4 because that's the overlap, and f of x is never 0. We're never dividing by 0. It's impossible. You don't even have to think about non-permissible values. It's a common domain. And admittedly, I think we've done this exact example before. I might have thrown it on the board earlier in the week. Now comes the... I've got you thinking one way, and now I'm going to ask you to think backwards. Yeah. What is this saying? This is saying A goes into F, then the result goes into G. So A goes in through F, and what comes out is some number. That number goes through G, and what comes out is 98. What did we feed in from the very beginning to get that 98 in the end? Well, this statement right here, everybody, is basically saying that on g of x, which is x squared minus 2, x is unknown, but y is 98. That's meant to be a question mark, right? Normally, you know what number goes in for x, and you put it in and you calculate y. Here, we know what number comes out. We have to work backwards and calculate x. So this means that x squared minus 2 produces 98. So if I solve that, I get x squared equals 100, which means x equals plus or minus 10. There's two answers to this question so far. The number that goes in here could be 10, or it could be negative 10. Now, how do we figure out what number originally went in to F? Well, F is 2x plus 4, and the number that comes out of it is 10. So we have to solve this, and that is a pretty simple thing to do. We subtract 4 from both sides and divide by 2. So A equals 3 is a number that makes it work. And you can, if you like, you can double check here by putting 3 through, then putting the 10 through, and seeing that you get 98. Yeah.
Would it also have to equal negative 7? Because it's plus and negative 10?
You mean here? Yeah, we're not done yet. The red one, you're absolutely right. The red one is a solution to this problem. But there's another solution, which is that 2x plus 4 would have to equal negative 10 as an alternative. And is that where you're getting the negative 7 from? Yeah. So when you solve this, you get A equals negative 7. There are two solutions to this equation, or to this question. J of h of A equals nothing. That means A, some unknown number, goes through H, the result goes through J, and you get 0. So this second part is simply saying that 0 equals log base 3 of x. Right? It's saying some number which we don't know goes in here, and we get 0 coming out. So we're solving that equation. That's pretty easy. 3 to the 0 equals x. This is 1. This part is saying that we don't know what goes in to h, but we do know we get 1. And, you know, I'm sorry to break it to you, but just because we're done with the trig units doesn't mean we're done with trig. Where is sine of a rotation angle equal to 1? Only one location at the top, but because trigonometric functions are periodic, it's not just pi over 2. It's any coterminal angle to pi over 2. And finally, and I know it's been a long lesson for something that's that you already learned about yesterday, but it's important we get lots of practice here. K of j of A is 8. A goes through j. That goes through k. That gives us 8. So if k of x is 2 to the x and 8 comes out, you have to figure out what value of x we're interested in to give us 8. Well, 2 cubed is 8. It's 3. If A feeds into J giving us 3, and J is log base 3 of x, then that means that 3 is coming out of log base 3 of x. And that also is pretty easy to figure out. It's 27, because written in exponential form, this gives you 27. Right. And that's it for the unit. As I said today, we're just using addition, subtraction, multiplication, division, compositions all at once sometimes, and more than 2 functions often. So you have some questions to practice. At the beginning of Monday's class, after we go through any questions, I'm going to give you a short quiz on chapter 10 stuff. Not on rational functions, but on the stuff we've been covering with operations and compositions. I'll shut my app and give you at least another 10 minutes here to work on some practice, okay?